Composition of functions. We're going to consider the graph below of f of x, which shows the population in thousands of a small town since the year 2000. And then the graph g of x shows the number of cell phone towers based on the population in that same town since the same year of 2000. So using our graphs, what is the value of f of 9? So f means we're using that first graph, right? Of f of 9, and what does it represent in the context of this example? Okay, so am I finding where y is 9 or where x is 9? Where x is 9. I literally changed f of x to f of 9. X is now 9, right? Look at my f graph. Here's f of 9. Where does that fall on our function? 600. Okay, so f of 9, the first question is what's the value? Now it's not just 600 though. There you go, 600,000. So what does that mean? So in context, so this first graph says years since 2000 and population. So we should use those words to interpret. It's the population. So the population is what? Population is 600,000 when? In 2009. Good. It's been 9 years, right? Since the year 2000. So that's just showing the population in the year 2009. Beautiful. All right, next question. We are going to go to our G graph. What is the value of G of 600 and what does it represent in the context of the example? So they took G of X, it became G of 600, so we have replaced the X value, thank you. So here is where X is 600. Where does that fall on our function? About 490? Is that okay? We all agree with 490? Sounds good. So G of 600 equals 490. So that's the value. Part 2 is interpret. What does that mean? So this graph shows populations in thousands, and then over there it shows cell phone towers. So we need to use those words. So when the population is what? There you go, 600,000. All right, my pen is being real annoying today. There we go. When the population is 600,000, what do we know about the cell phones? There are, I'm going to say approximately, 490 cell phone towers. Do we remember doing things like this? Getting points, interpreting them with real world stuff? You have done it before. It's been a little bit, but you have done it. Okay, the next one looks fun. What is the value of G of F of 9? And what does it represent in the context of the example? Okay, so we have two things going on. This is called a composition. Okay, F of G, a G of F of 9. You did this in Algebra 2. In Algebra 1. Ha! You're in Algebra 2. You took 9 and evaluated that for F. Well, didn't we do that in our first example? What was F of 9? We already know what it is. The 600, yeah. And then it wants me to take that answer and plug that in to G. So then we're going to do G of 600. Well, didn't I just do that? What is it? About 490. So now let's put those all together. So my two interpretations that we just did, I can mash together to say what about this small town? What year is it? All right, so in 2009, we can say that there's how many cell phone towers? 490. There are approximately 490 cell phone towers. Okay, so notice the connection between the graphs is population. Population is the Y value in our first graph, and then that becomes the X value in the second graph. So if I know population, I can connect years to towers. Okay, and that's kind of what the next question is asking us to put down in the words. In general, what can we say about G of F of X? So the input of our entire function, G of F of X, is the output of just F of X. So we used F of X to plug into the G function. We used one to plug in to get to the other. Okay? And remember, that means that they connected the population. So if we know the population during a certain year, I can then find how many cell phone towers are in there in that same year. So that's the context. So if we know population for a specific year, we can determine cell phone towers. Remember, input is X and output is Y. So that's what matches. The output from my F function equals the input of my G function. My Y's are population, and then my X's become population. All right, this is all called composition of functions. Okay, it's a method of combining functions together. The output or the range from one becomes the input or the domain of the other function. Sometimes we use this symbol. It's an open circle. Okay, that represents a composition. And sometimes it looks like this, where you literally have one function plugged inside of the other. And we read it as F composed with G of X, or I usually say F of G of X. This one's more common and quicker. All right. So let's do some more composition of functions, but not with context behind them. I wanted you to show you how they're connected, how we use one to get to the other. The back is going to be very algebraic. We're just plugging in, finding new functions. Ready? Yeah. Okay. The first couple ones we're going to do, they have values that we're going to plug in. And then the last two, we don't have values. So they are going to act a little bit differently. Okay. The first one, it says find F of G of 2. So I'm going to rewrite it as F of G of 2. I like to write it like this. Y'all know I'm very visual. So we're going to start from the inside and work our way out. Okay. So I'm going to plug 2 into the G function, figure out what that number is. So when you plug in a number, you get a number. Get that value, and then we're going to take that value and plug it into F. Okay, so we're composing. So first things first, G of 2. So we're using this function. So I've replaced my X with the 2. Do we agree? So instead of saying negative 4X, we have negative 4 times 2, which is what? Negative 8. So since I know G of 2 is now negative 8, I can plug that value into our F function. My F function, sorry I printed weird, It is x squared minus 5x plus 2. So wherever I see an x, we are now replacing it with a negative 8. So we have negative 8 squared minus 5 times negative 8, and then plus 2. I don't know why that's on the end. Sorry. All right, we can do this. What's negative 8 squared? Woohoo! What is negative 5 times negative 8? Plus 40. Then we have that plus 2. What does this give me? 106? So my composition, f of g of 2 equals to the value of 106. We plugged 2 into g, got that output, and then that became the input for my f function. Okay. Do you think if I switch the f and the g that we're going to get the same answer or a different answer?
Different answer.
Think it'll be different? Let's see. So now I have g of f of 2. So we have flip-flopped. We have g on the outside and f of 2 on the inside. So 2 is going to get plugged into f first this time. So f of 2 equals, we have 2 squared minus 5 times 2 plus 2. 2 squared is negative 5 times 2. And then plus 2. Come on, my battery is going. You should have gotten what? Negative 4. So what are you going to do with that negative 4? Now you're going to plug it into G. Yep, go ahead and do that while I get my pin taken care of. So how do you set this one up? How do you plug negative 4 into G? What does that look like? Negative 4 times negative 4. Yep. So we get what? Ooh, positive 16 this time. So our final composition is that G of f of 2 equals 16. So did I get a different outcome? Heck yeah. Lesson here, does order matter? Does order matter? Absolutely. $16 in your account versus $106 in your account. That's a difference, right? Pretty significant one. So make sure we do the order first. Work our way inside out. Okay? I would like you to please try the ones below it. F of G of negative 3, and then G of F of negative 3. So again, we're flip-flopped. We're going to assume they're different answers. They should be. Order should matter. So you work on this. You're with the partner. One of you do one. Have your partner do the other. So one of you do F of G of negative 3. Have partner do G of F of negative 3. Okay? All right. Nate, what did y'all get for F of G of negative 3? 86. All right. And then Cole, what did y'all get for the other one? What is it? Negative 104. Good. Yes, they are right. Do we need to see them? Do you have questions? The second one?
No, Brandon needs to see this.
Okay. Our second one, we take negative 3 and plug it into which one first? You have to plug it into F first. Okay. So F of negative 3 is going to be negative 3 squared minus 5 times negative 3, and then plus 2. So this becomes 9, this becomes positive 15, plus 2. So that is 26, yep. And then you're going to take that value and plug it in to G. So G of 26 is now negative 4 times 26, which is where you get the negative 104. All right, so you plug in a number, you should get out a number. Okay, your input should match your output. Now, these two guys on the side over here, I'm not plugging in a number, am I? No, x is still x. So what we're doing instead is we're plugging in entire functions. Okay. So look at this one. Technically, if I plug x into g, don't I still just have the g of x function? Right? So I'm not changing anything. So think of the process as the same. So I'm still plugging in an x for x, so it's not changing. But now I have to take x squared, and I have to plug that into f. So f of x squared means wherever I see an x in my function, it is now an x squared. So instead of x minus 3, it is now x squared minus 3. Can I do anything else with that? Nope. So f of g of x is going to equal x squared minus 3. So here, if we don't change our value, if x stays that way, you should still get a function out of it. So here, that's called a composition of functions. The first four were a composition of values. These are composition of functions. So again, if I flip-flop them, do you think order is going to matter? Oh, yeah, it is. So this time, take x and plug it into f. So I have f of x, which is still just going to be x minus 3, right? And now we're going to take all of that. What color did I use? Orange. Now we're going to take all of that and plug that into g. So wherever I see an x, it's now going to be an x minus 3. So instead of x squared, what's it going to be?
X minus 3 squared.
X minus 3 squared. Ooh. So what do we get to do? FOIL, FOIL. Yes. We get to write it out twice. Anything squared means it's being multiplied to itself. So we should get x squared minus 6x and then plus 9. So g of f of x is x squared minus 6x plus 9. So you're going to change your x's to like entire functions. This is what's going to happen. Questions about composition of values or composition of functions? Yes.
So my first one, with the 3 benefit of x cubed. With the other x.
What other x? The only x that was there, right, it was x squared. But x is not allowed to be x anymore. X is now x minus 3 completely. So instead of x squared, it's x minus 3 squared. Yep. So the original x is not there anymore. It got completely replaced. All right, ready to play match game? Woo! Y'all you are just full of energy today. I'm sure it's coming through great in the video on like just how excited y'all are about math today. So the way our computers work, by the way, they don't extend this all the way across. These are square roots. So if you want to kind of go in and draw those over, you can. All right, so we have, 6 different compositions now. They are all function compositions. There's g of f, there's h of g, there's f of g, g of h of f, and f of h. Woohoo, good times. Okay, and the functions that we are using are over here on the side. We are using the f function of 2x, g function of the square root of x, and then our h function of x squared plus 3. Okay. All right, which one do we want to do first? You just want to start from the top, work our way down? Okay. I'm going to do a couple of them, and then I'm going to let you do the rest. Does that make sense? So let's do a couple. All right, g of f of x. So I have to take x and plug it into f first, which is just going to be 2x. Do we agree? So I'm going to take 2x and plug that into g. So instead of g of x, it is now g of 2x, because we're plugging our f function into the x values in g. So g was the square root of x, but now it's going to be the square root of 2x. Can I do anything else? No. Is that on my list somewhere? Yeah, it's my second one. Boom. So those match up. All right. H, are we cool if I just move down? We're good? All right, hog. H of g of x. So plug x into g. Well, that means I just have the function square root of x, right? We're taking that now and plugging it into h. I'm going to do it over here for all your room. So we have h of the square root of x. H was x squared plus 3. So now it's the square root of x squared plus 3. Well, what is the square root of x squared? X. So this just becomes x plus 3. Do we see that somewhere? Yeah, down here. One more together? Okay.
Good job.
F of g of x. So x goes into g, which is the function square root of x. And now we're going to plug that into our f function. So instead of f of x, it is now f of the square root of x. 2 times x is now 2 times the square root of x. So that's just 2 times the square root of x. Where's that? C. Down there. Good. All right, you and your friends work on those last 3. And then we'll come back together and see how we did. All right, beautiful people, check your answers with mine. D matches with the square root of x squared plus 3. E matches with 4x squared plus 3. And F matches with 2x squared plus 6. Do we need to see any of it? Which one? E? Okay. So we're taking f of x and plugging it into h. F of x was 2x, right? So the x that's in h, this guy, is going to get changed to be 2x. So this is E. So we're doing h of 2x. So that's going to be 2x squared plus 3. 2x squared is 4x squared. And then there's your plus 3. And there's no other combining you can do. We good? We okay? Any questions at all? Okay. Yes.
Why do you keep this square?
Because it's still part of my function, right? The square is still here. The only thing you're changing is just the x. So your x gets changes to another function completely. So the variable x is now the function 2 times x. Still being squared. Like the other ones, there was still a square root, right? That doesn't go away. You're just physically changing the x. Okay. Okay, lovelies, your worksheet today has an answer bank at the bottom. So you can kind of check and make sure you're doing things right as you work. So your answers should show up somewhere on the bottom. So if you get an answer and it's not down there, Go back and try again. Okay? So work on that the rest of today. Today, if you get done, I will gladly stamp you. And then tomorrow we're going to divide. Long division and synthetic division.